Hey everyone, good afternoon. We have an exciting series in front of us here. We will be discussing basically an introduction to 3D concrete printing, all things related to concrete printing here. It'll cover the basics. It's for professionals, it's for architects, for students, anyone that wants to just know more about a lot of the fundamentals of and what 3D concrete printing is. So we have my co-host Sean Nugent with us today. So hey, Sean, good afternoon.
Afternoon, everybody. Happy Monday. Thanks so much for setting this up, Johnny. Yeah, pretty cool. I love talking about this stuff. There is blue ocean opportunity in concrete printing, also with mortars, also different types of geopolymers, but excited to dive in and have a great casual conversation about all things 3D printing and housing.
Beautiful, man. Beautiful. So as the series unfolds here, we will discuss, essentially we have like kind of some topics to discuss. And then within that, we'll break it out with a little more resolution. And we'll have a few items to talk about within each of those headers, if you would there. So let's kick it off with a question. So let's give us a little bit of the history and the development of 3D concrete printing. So where did this thing come from, and kind of what's some of the background there?
Well, I mean, 3D printing, as we all know, we've seen it for multiple years in schools, educations, professional services. In the construction field, from my knowledge, it goes back to like the 40s. There's a thing called the Urschel wall building machine. I'll put a link in the show notes. You guys can check it out. It's one of the earliest forms of 3D printing that I could find from earthen materials. They only used it for a couple buildings, but from there, of course, 3D printing has expanded from desktop printers. And it's a similar setup. You know, you've got an X and Y coordinates, and you can just 3D print with multiple types of materials on a larger scale. But it's not just like your traditional 3D printer. They've got some great machines that are robotic arms. Some are going to be polar printers, and some are going to be gantry, which are more traditional 3D printing machines. And they've got a plethora of different types of material to use. And the material science is what I find very intriguing. I see in time there will be no cement or cementous materials in the mixes at all. And the possibility to go totally green is something I'm very excited about.
Amazing. Let's drill into one of the things that you kind of mentioned, that is with the actual machines. And you mentioned three terms there, gantry, polar, and then also just robotic arm. And then of course the material itself. So let's talk a little bit more on, the key components and processes of 3D concrete printing. So how do you get this, concrete somehow sitting there, in a shape that you want?
Well, think of your traditional 3D printer that you'd see in, a lab or even in your house. You're going to have a spool of material that's going to be fed into the printer, and depending on the heat dynamics, it's just going to be laid layer by layer by layer. And when it comes to concrete printing, it's a similar discussion. It just comes down to a mixer pump or mixing pumping system or something to feed the material through a hose that would get to the layer point. And the difficult thing is getting a consistent mix from where it mixes all the way through the pump. So when it comes out, your consistency is not going to be the same as it's being mixed through the pump to where it actually comes out. So there's different things you can do to advance the setting times, to retard the setting times, and it all depends on humidity, temperature, sunlight, water. It's complicated, but there's a lot of amazing people working around the clock with multiple different machines and materials, and you can see that by all of the amazing 3D printed houses that have been built in the United States and around the world.
Awesome. And also the audit, you can hear, folks, all the different factors that influence a good print. Although, Sean, we both have seen, especially in recent months, essentially, some teams really progressing rapidly, and the end product really, it looks good to the eye. Some stuff literally looks bad to the eye, and some of the more recent efforts, if you would, by teams that have started some time ago and then are now continuing that. They're looking, so typically, not always, but you see something that looks good to the eye. Typically, it's also it's a sound construction methodology as well. And that is just another piece. So I guess speak to the progress of teams as they do 1, 2, 3, 4 houses. What does that look like from your perspective?
I think the more you print, the process. You can learn, you can grow. I mean, there's some companies out there, they want you to walk into a house and not know it was 3D printed. And I think that's the
Mm,
goal for
yeah.
teams out there. And some people really like the aesthetics of knowing that the house was 3D printed. Some people like the cool designs. You can have, different types of layering effects to have it smooth. You can smooth it over, or you can actually see layer by layer. I don't want to call it the sausage effect, but there's multiple ways to do it. But there's been more than a few houses I've seen through video walkthroughs where you would not know it was 3D printed. And I think in time, that's going to be a great selling point for a lot of people, because what is a 3D printed home? Well, I want it to look like my traditional home. I think very soon you're going to see more people going, that sounds great. You don't even know. I'd like one of those, especially if you can lower the price point of entry. A lot of these houses, especially in the accessible housing market, I think there's a lot of advantages to it.
Amazing. So as we turn the kind of the final corner here on our episode today, compare, if you would, for me, Sean, the things you've noticed between, I guess, some of the fundamental differences or characteristics, and we've touched on a few, but just draw the distinction more clearly between traditional, could be framing, wood framing, or maybe a more appropriate like concrete block, between concrete block or poured walls, and the benefits that we see in a 3D concrete printed foundation or wall structure.
Yeah, there's a lot of misconceptions when people hear 3D printing. They think you push a button and you knock out houses like they're McMuffins. That's not the case. A lot of times what you're literally doing is you're replacing your traditional framing, your wood that goes into it, your sheetrock that goes after it, your insulation. So you're actually just kind of doing the exterior and interior walls. Some teams, they actually just like doing the exterior walls around the outside of the house and do traditional on the inside. But you have a choice to do either or a mix of both. By doing 3D printing, I mean, the speed at which you're going to get the house up is going to increase exponentially. There's limitations right now to the printer head and how much it can actually print per day, and teams are tackling that. But there's
So even if you want, just to that point, even if you wanted to, like, I can only print so fast, I can't just like, oh, I'm going to have this house done in an hour, right? I mean, like, there's a time limit on how fast you can lay concrete down, correct?
And also, it's easier to print, I would say, if you're doing houses, larger structures than smaller ones, because you
Yes.
can increase the speed of the machine, because every time it goes around, it's got to cure so the next layer can be put on top of it. But as of now, I mean, it's been instances, but you're not 3D printing roofs or windows or doors or anything like that. So once people just realize, look, we're just going to be printing very comparable to a CMU block design, and you're just trying to go above and beyond AC 509 standards. All that is if you're building with block, you're going to have your rebar every so many feet, and it's going to be very similar in the design. But as we know, the amount of skilled labor it takes to get a block wall up, a lot of the trades, there's such a large shortage of builders in the United States. I think every month they were saying there's 300 to 400,000 jobs in the construction industry that need to be filled. And this is a new way to get younger people excited about the next stages of construction 4.0. And I think 3D printing is going to be an integral part of that. I think they're very early. I think the machines today, compared to where they're going to be in 3 to 5 years to 10 years out, are day and night. There's a lot of great companies out there trying to automate more than just the wall process, to speed it up, to make it stronger. And I'm really excited to see every build that's unfolding in this year and beyond.
Awesome, man. You mentioned one thing right there, and just for, I guess, audience curiosity, give us a couple of names of who in the machine building space, if you can, who you've seen some real innovation out of. I know there's some large manufacturers out there around the world and US based and other things. Who are a couple of the names that kind of are leading the pack there?
I mean, there's a bunch. There's a ton of great videos online just by putting in 3D printing. But I love a lot of the work that Diamond Age is doing. They're kind of pushing the envelope a lot more on automation. So instead of just having a printer, they're looking more into the robotics end of it, to have on your print head multiple tools that can do multiple jobs as well. And I think in time, a lot of the other printers will follow along that. But take a look. If it's Atlas Core, if it's Black Buffalo. Cybe's doing an amazing job. I mean, I have a list of like 90 different manufacturers who are working on this around the globe, including
Incredible.
Cobalt. And I just
Yes.
think it's going to continue more as we go. But I'm very excited about the thoughts of not just having it print, but to have other aspects of the house build automated. And that's where I think it can really catch legs, catch fire, and build faster, stronger, and in time more affordable. Because as we know, there's a shortage of anywhere from multiple different numbers, 5 to 7 million houses needed in the United States alone. And it looks with, building sentiment, I want to say it's at an all-time low, but with interest rates going up, it looks like we're going to be building less over the next coming years. And we need to do the opposite.
The exact opposite, right,
build more.
Sean? Yeah.
And I think by using this technology, if you can get to the point it can scale, it can have a positive impact on multiple different types of home designs around the United States and the world.
Amazing, man. All right, folks, that's a wrap for our first video in the series of Introduction to 3D Concrete Printing. So thank you for tuning in. We'll have a great episode every week at least, and we'll cover, again, pretty comprehensively, but at the 10,000 foot view, so you know what's going on, you have a sense, you have an understanding, and this is for really anyone that has the, professionals, architects, students, and just even builders that might be interested in this space here. So until next time, Sean and I are signing off. Thanks, Sean.
Have a great week, guys. Thanks so much.